Hello and welcome to this brand new video of the channel, that is Everything We Believe in Universe. Humans have always intrigued by nature, and why not? There is no limit to its beauty and enigma. We have been constantly increasing the scale to which we can define our physical reality, both in the microcosm as well as the macrocosm. In the microcosm, we have boundary of the observable universe with the order of 10 to the power 26 meters of radius. In the microcosm, we have the lowest possible length called Planck's length, though not observed yet, in the order of 10 to the power minus 35 meters. There is a concept in nature philosophy called atomism, reference of which are found in the ancient Greek and ancient Indian philosophical traditions. Atomism is a natural philosophy which says that the physical world is comprised of fundamental indivisible components called atoms. The word atom is derived from the ancient Greek word atomos, which means uncuttable. As it has been proven to be correct, we have found this fundamental block of elements and named it atom, though in 1897, by the discovery of the first subatomic particle, that is the electron, by J.J. Thomson, this myth that we stumbled upon the very basis of the universe, the fundamental uncuttable particle, was broken. But the misnomer atom still used. Despite this, the idea that there is something fundamental which is basic building block was fueled. Initially, in physical sciences, matter and energy were considered distinct. But after Einstein proposed the special theory of relativity, there came a legendary relationship between by the equation E is equal to mc square. This states that the energy and mass are interconvertible for each other. Under certain conditions, for instance, in nuclear fusion or fission, some part of the matter is converted into electromagnetic radiation. The classical period in physical sciences was considered to be the final phase of the physics, and it was thought that there is some tweaking to be done here and there, and then the physics would be done. But as they went the scale at the atomic and subatomic scales, the classical rules that worked perfectly fine at the macroscopic scales started failing. This emerged the weird and spooky literature of quantum physics. Comment down below 3 major problems which led to the advent of quantum physics. In parallel was this debate of defining the exact nature of the atom ongoing. Initially, J.J. Thomson came with this plum pudding model where he stated that positive charge was even distributed like a pudding and electron embedded like the plum. This was completely overturned by Ernest Rutherford's iconic alpha particle scattering experiment, which said that much of the positive charge and mass was concentrated in the center, which we now know as the nucleus. He is technically responsible for the discovery of proton. Then eventually neutron, a particle devoid of any charge, was discovered in 1927 by James Chadwick. For decades, these were considered fundamental elementary particles until 1960, when physicists started firing electrons on protons, and thus they revealed the internal structure of protons. That they further were made up of elementary particles called quarks. Then came the era of modern physics, which saw a development in modeling and discovery of many particles, also the fact that light behaves as a matter, and radiation was proposed by Einstein, which led to the conclusion that a completely described particle, both sometimes wave nature, is to be considered and sometimes particle. As new particles and their interactions was proposed, the physics started becoming more and more elaborate and deep. And then eventually, around the mid-1970s, a clear classification of the elementary particle with comprehensive theories of fundamental interactions except gravity was finalized, which came to be known as the standard model of particle physics. It is divided into two kinds of particles known as fermions and bosons. Fermions are those particles that have 1 by 2 integer spin and obey Fermi-Dirac statistics, while bosons are the particles that have integer spin and obey Bose-Einstein statistics. There are 12 kinds of fermions and 4 kinds of bosons. Fermions are particles that matter consists of, while bosons are considered the force mediators. The photon is responsible for the mediation of electromagnetic interaction, W and Z bosons for the weak interaction, and gluons for the strong interaction. All these were described in a theoretical framework by what is known as quantum field theory, which is made by unified classical field theory, special relativity, and quantum physics. According to this theory, any particle is excitation in the corresponding field, and the interaction between different combinations of the excitation produce various particles and forces. But in all, grandness is still a fundamental issue. The whole particle framework in quantum field theory for the particles has been space-time continuum as its base. For gravity, the corresponding field is the same space-time continuum itself. So what to base quantum field theory for gravity on? Also, this theory needs 19 free parameters like mass to fully describe the all particles and interactions. There is this theory that called M-field theory, which at least on paper solves this problem by considering loop-like string instead of a point-like particles. So what is that can penetrate the Planck scale and surpass the problem caused in the quantum field theory? M-field theory is what we commonly known as superstring theory. It is all the superstring theories combined into single one. The idea behind it is very simple, that all the particles, fermions and bosons are made up of tiny strings, and by tiny I mean very tiny, of the order of Planck's length 10 to the power minus 35 meter, are vibrated into 11 dimensions according to the M-field theory. The vibrational model are standing waves on these strings. A different set of complex modes makes for the different kinds of particles and their properties. Therefore, only one parameter tension in the string is required to fully describe the particle with their properties as opposed to the standard model of 19 free parameters. This has gotten the tail of the physicists as it is the strongest contender right now for the theory of everything, which describes the particles and the fundamental interactions. The issue with this theory is it does not make any testable predictions. There are 10,500 string theories. Among them lies one perfect description of our universe. But despite this, due to the elegance and mathematical consistency, physicists are hoping that it is right or at least the right path. So what do you think? Have we come to the end of atomism and finally found the fundamental building blocks of the universe? Or it is just one of the infinite layers of the fabric of the unknown? Comment your opinion down below in the comments. I would like to answer all the comments. If you have not subscribed to our YouTube channel, please do subscribe as we will bring science and universe videos to you. If you like the video, kindly press the like button and please share among friends. Thanks. Bye bye. It's Kusmakarpan signing off. Thanks for watching.